Greetings to all. I'm Himanshu from Team 1. We're making this video because this is a project from our instructor and he said he would grade us for this. And another reason is that we are scared of failing the subject. Just kidding. We have chosen a topic that is very interesting and I hope you find the same after watching this video. But before starting, let's watch a clip from a superhero movie.
Where'd that come from?
It's nanotech. You like it?
If you have not been living under a rock for last decade like normal humans, there is no need of introduction to this character. He is one and only Iron Man. By this, you can guess our topic. Yes, our topic is nanotechnology, especially nanotech in healthcare. Before starting with the main content, I would like to share this podium with my co-presenter Anshika for introducing this topic.
Hello everyone, this is Anshika. Let's start with introduction. What is nanotechnology? Professor Norio Taniguchi coined the term nanotechnology. The prefix nano comes from the Greek word nano, meaning a drop. Hence, nanotechnology is the science and engineering of small things, in particularly things that are less than 100 nanometers in size. What are nanoparticles? A nanoparticle is a small particle that ranges between 1 to 100 nanometers in size. Undetectable by the human eye, nanoparticles can exhibit significantly different physical and chemical properties to their larger material counterparts. Nanotechnology in healthcare. Nanotechnology is already leading to dramatic improvements in healthcare. From fitness monitoring and diagnosis to eradicating cancer cells at cellular and even the subcellular level with enhanced imaging techniques and high-performance sensors. Current condition of healthcare. Even though there have been many breakthroughs in healthcare industry in past century, still many diseases that can be prevented and cured have been overlooked due to lack of infrastructure and proper equipment. Let's talk about downfalls of current healthcare industry. Failure mortality rate due to surgeries. In a case study, a total of 22,788 surgical procedures were performed with an operating mortality rate of 0.71%. Mortality rate following elective surgery was 0.71% and following emergency surgery was tenfold higher. The main cause of post-operative death was sepsis or infection. Emergency operations, increasing age, and major procedures significantly increase mortality risk, which could have been easily avoided with use of proper and adequate nano instruments which were unfortunately unavailable at that time. Now, cancer and deaths due to it. Cancer deaths per year is the second leading cause of death in the world. The death rate is the number of deaths divided by the number of people. The WHO most recent figures of cancer death globally were: number 1, lung cancer, 1.76 million deaths. Number 2, colon rectal cancer, 8,62,000 deaths. Number 3, stomach cancer, 7,83,000 deaths. Number 4, liver cancer, 7,82,000 deaths. Number 5, breast cancer, 6,27,000 deaths. And melanoma is the fifth most common cancer type. The cancer deaths are rising because of smoking, poor diet, physical inactivity, fewer pregnancies, and lack of proper equipment. This can be avoided by new innovations that currently taking or will take place in nanotechnology. Now, I would like Ravi to continue our topic.
Hello everyone, let's talk about new opportunities and solutions. Nanobots or nanorobots. Nanorobotics is an emerging technology field creating machines or robots whose components are at or near the scale of a nanometer. Due to this, many applications which were thought to be science fiction are real and within reach now. First, accurate on-site drug delivery technology has always been a hard nut to crack in the pharmaceutical research field. The most ideal condition is that the therapeutic dose of a drug is transported directly to the targeted organs, tissue, or cell to produce a marked and desired effect. Second, a proof of concept nanorobot design could be used to target cancer cells by the glucose consumption and delivery drug payload in response to human interaction. Third, even though natural organ regeneration is limited to species like Hydra and salamanders, most cyanomes with regenerative medicines are the stem cell therapies, as stem cells are responsible for engineering an organ's original complexity during development. But in future, it may be possible that nanobots using stem cells can artificially direct proteins, collagen, glycogen, and other enzymes directly to the organ site for complete regeneration, diagnosis, or data collection. As these particles are as small as the smallest viruses, they can be put inside our bodies to monitor smallest changes that are occurring in our bodies at a point of time. First, earlier disease detection. A method for early detection of a disease uses nanoparticles that form clumps when they attach to proteins or other molecules that indicate the disease being tested for. The test is intended to be inexpensive and simple to perform. Second, nanomaterials are increasingly used in diagnostic, imaging, and targeted drug delivery applications, and can even to facilitate the development of personalized medicine, in which patient therapy is tailored to patient's individual genetic and disease profile. Third, nanotechnology can be used in neural tissue growth, also adapt devices for interference of neural networks, especially nanomedicine, where technique is involved and the role function in which the nanoparticles apply to central nervous system, CNS, and imaging of CNS. Now let's talk about nanomedicines. Nanomedicine is a medical application of nanotechnology. It has provided the possibility of delivering drugs to specific cells. Using nanoparticles, the overall drug consumption and side effects may be lowered significantly by depositing the active agent in the morbid region only and in no higher dose than needed. Targeted drug delivery is intended to reduce the side effects. For example, most chemotherapies have very short lives inside the bodies and are very likewise to affect the health tissues and immune system along with it. Introduction of nanomedicines will help retain the drug in the body for long enough for effective treatment. Second, cancer continues to be one of the most difficult global healthcare problems. Although there is a large library of drugs now that can be used in cancer treatment, the problem is selectively killing all the cancer cells while reducing collateral toxicity to healthy cells. Though nanomedicine will be very convenient for treating cancer, it would be ignorant to limit its application to only treating cancer, as the application of such an apparatus can be even beyond our imaginations. Now I would like to pass this flag to Shruti.
Hello everyone, this is Shruti, drawing your attention to pros and cons. Firstly, pros. Rise in life expectancy or health quality. Nanotechnology has greatly contributed to major advances in computing and electronics, leading to faster, smaller, and more portable systems that can manage and store larger and larger amount of information. Also, nanotechnology is already broadening the medical tools, knowledge, and therapies currently available to medical field, thus treating diseases that were untreatable in past. Let's talk about cons. Lack of uniformity of toxicity. Nanomaterials of different composition, size, or shape may be toxic to a different set of cells at different set of exposure conditions. The target cell and the target moieties for toxicity varies with the composition, size, shape, charge, aggregation, coating, and solubility of nanoparticles. Also, lack of understanding of impact on biological system. Impact on health and safety issues still unclear in terms of cellular or organ toxicity, genotoxic or carcinogenic. These materials are small enough to be inhaled, and the particles accumulate in lung alveoli to induce inflammatory changes or say carcinogenic effect. This would be of a prime concern because the workers will be under the threat of occupational hazard. Lack of in vivo or interbody monitoring systems. Substantial infrastructure for in vivo analysis of the nanomedicines, inability to monitor multiple probes, and patients need to be admitted for analysis are the major factors that preclude or prevent optimization of the biological activities. Lack of well-trained workforce. High energy consumption due to which production cost is very high and restricted accessibility to people. This is a major hindrance for the goal to be achieved for POC or point of care testing to the remote areas. And an unignorable point is that impact on environment. Though domain of this field involves manufacturing of nanoparticles which requires high energy input and also generates large amount of waste. Hence, we are still far away from calling it a green or environment friendly sector. Last from my part but not the least, let's talk about investment to profit ratio. As a satisfactory definition of profit and investment are hard to find, and as from time of investment to the point of harvesting, return may vary. So recording and monitoring consumption or generation of the funds can be very hard. By the end of 2004, venture capitalists had already invested $1 billion in nano companies, nearly half of that alone in 2003 and 2004, which clearly suggests that the future winner in the sector will be well-funded companies and institutes that can attract and nurture the scientific and technical expertise. Now, I would like to pass it on to Himanshu.
Thanks Shruti for your input. As we have seen quite a many shortcomings and drawbacks, it would be very rude to end this video at this point without talking about current improvement and our suggestions. Our first suggestion would be biosynthesis of nanoparticle. As need of eco-friendly production method increases, we need creative and effective ways to achieve this goal. One particular method can be manufacturing with help of organisms. Although it sounds very unrealistic, scientists have proven the former statement false. Nanoparticles are biosynthesized when microorganisms grab their target ions from their environment and then turn metal ions into elemental metal through enzymes generated by cell activities. Scientists have successfully created gold, silver, cadmium sulfur nanoparticles. Our second suggestion would be using non-toxic materials. As we have already discussed in previous slides about toxicity of currently used materials, we need to actively search for new recipes and ingredients to produce new and less toxic or body neutral material for nanomaterial production. Last but the most impactful suggestion would be making nanotechnology accessible for general population. As it has been recorded in the past that things that are more accessible, the faster is the development and bigger is the pool of innovative ideas. One such example is internet. Since its entry in public domain in late 80s, growth has happened at an exponential rate. Same can be expected for any other technology like nanotech. At last, I would like to conclude by saying, if we talk about new opportunities and solutions, nanorobot and organ regeneration, which were dreams of past, are now achievable at some level. Now, some are even near perfect. Although it has a ginormous production cost and is not much feasible, nanotechnology is improving day by day, thus reducing its drawbacks to be more feasible and available at a convenient cost for general public. It is clear that nanotechnology in future will be panacea in healthcare systems all over the world, maybe even Mars too.